Concept 3.4, polynomial functions graphs. In this concept, we're going to talk about taking what we've learned in the past two concepts and applying it to graphing polynomials. The first thing we're going to talk about is multiplicity of zeros. So in the last concept, we learned how to find zeros given a polynomial. And now, depending on the multiplicity of each zero, something different is going to happen at the graph. So first of all, if we have an even multiplicity of a zero, then that means that our graph is going to bounce. So right here in my example, I have a graph and an equation down here at the bottom. So one of my zeros from this equation is going to be x equals 2, and it has a multiplicity of 2 because of that exponent. At 2 on my graph, I see that my graph comes down to the x-axis and bounces back up. Again, that's because the multiplicity here is even. Next, if we have odd multiplicity, so like the 0, x equals -3, its multiplicity is 1. That means that on my graph, I'm going to cross the x-axis. The other option is our graph could do something called wiggling. So my 0 of x equals -1 has a multiplicity of 5, because that's the exponent on there. It's an odd multiplicity, so I'm going to cross the x-axis. But at the x-axis, I'm going to flatten out just a little bit, called a wiggle, before I go up. So this is a wiggle. Next, we have end behavior. The end behavior of my graph is just what are the arrows at the end of my graph doing as they go to infinity or negative infinity. So take a minute, pause your video, copy this down, and then restart it, and I'll give you some ways that I remember which end behavior matches up with which degree and which leading coefficient. Okay, let's start by looking at our leading coefficient. So whenever we have our equation, the very first term, whichever one has the highest exponent on it, that's going to have our leading coefficient. And we're looking to see if that coefficient is positive or negative. I always remember that that's how my graph is going to end. So if it's a positive leading coefficient, I'm going to have one of these top two options where my graph ends going up, shown with the green arrows. If I have a negative leading coefficient, my graph is going to end going down, shown with the red arrows. Next, we consider the degree of the polynomial. Remember, the degree is just the highest exponent. And we look at whether that degree is even or odd. If the degree is even, both of my arrows are going to end up going in the same direction. So either up, up, or down, down. If it's an odd degree, my arrows are going to go opposite directions. So either down, up, or up, down. Let's try some examples where we determine the end behavior for these functions. So let's look at function f. We're going to find the leading term, which is always the term with the highest exponent. And we're going to look at the degree and the leading coefficient. Starting with the leading coefficient, which is 1, that's positive. So my graph for f needs to end going up. So I know my options are either going to be b or c. The degree of function f is even, so I know that my arrows need to go in both directions. So my answer for function f is going to be graph C. Pause your video and see if you can figure out which graph functions g, h, and k match up with. Here are the answers that I got. Graphing a polynomial function. So to graph a polynomial function, we're going to follow the 3 steps below. Number 1, we're going to find the real zeros of function f and plot them as x-intercepts. This is what we did in the last concept. Step 2, we're going to find the y-intercept by plugging in 0 for x and plotting that on the graph. In step 3, we're going to use end behavior and multiplicities, so whether we're crossing, bouncing, or wiggling, and any other points we need in order to complete the graph. Let's try an example. So step 1, find the real zeros of function f and plot them as x-intercepts. Remember, we start doing this by finding p over q and writing out all of our possible zeros. So pause your video, write p over q, and write out your list of possible zeros. Restart the video to see what I get. Hopefully you got the same as me. Again, this concept, this idea is from the previous section that we learned. Next, what we're going to have to do, still from the previous section, is test each of these. So I'm going to start with -1. I'm going to test it and see if it is a 0 of my function or not. If that's not it, then I'm going to test 1, and then -2, and then 2, so on and so forth. I will eventually find 1. Okay, so first I'm testing -1 using synthetic division. And I get that x equals -1 is not a 0 of my function because I didn't get out 0 right here. So now I'm going to test 1. And since I end up with 0, that means that x equals 1 is a 0 of my function. So now I can write my equation as 2x squared plus 7x plus 6 times x minus 1. Remember, we're changing the sign whenever we plug it into our factor. Now that I have a quadratic left, I'm going to take that and I'm going to factor it to get my factored form. So my factored form of f is going to be 2x plus 3 times x plus 2 times x minus 1. Now I can set each of those factors equal to 0 and solve, and I get the following x-intercepts: -3/2, -2, and 1. Step 2, we're going to find our y-intercept, and we're doing that by plugging 0 in for x. When I plug 0 in for x, I'm just going to get out -6. Hopefully you knew all those x terms would just go to 0. So my y-intercept is the point 0, -6. So now we're almost ready to graph our polynomial. We have our 3 zeros. All of them had multiplicity of 1, so we're going to cross at each of those zeros. We have our y-intercept. Now we just need to figure out what our end behavior is. What should our ends do on the graph? Our leading coefficient is 2, which is positive, so we're going to end going up. And our degree is 3, which is odd, so my arrows are going to go in opposite directions. And here's what our graph is going to look like. I have dots on my x-intercepts and a dot on my y-intercept. And then according to my end behavior, I drew the graph through those points. Now this isn't perfect, it's just a sketch. I didn't really specify how high this part goes right here or how low this part goes, but we're just sketching these graphs. Example 4, we're going to go through the same 3 steps, but this time my function is already factored for me, so step 1 is much easier. I can see that my intercepts, I've got x equals 1. It's got a multiplicity of 1, so I know I'm going to cross at that point. Then I have x equals 3, multiplicity of 1 again, so we cross. And then I have x equals -2, which has a multiplicity of 2, and therefore we're going to bounce off of that 0. Next, we're going to find our y-intercept by plugging 0 in for x. Once you plug in 0 for x, you could put this whole piece right here in your calculator, or you can simplify it by hand like I did. So our y-intercept we get is the point 0, -12. And now we're ready to bring all this information together and find our end behavior. So notice that we don't know what our leading term is necessarily. We're just going to multiply together whatever is out here, 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 and here but we're also going to keep in mind that this would be an x squared if I were to do box method. So for my leading coefficient, we're going to have negative x to the fourth. So my leading term is negative x to the fourth. My leading coefficient is -1, degree is 4. When I drew my graph here, I put my x-intercepts on. I bounced off of -2, and I wasn't able to fit 0, -12 on my graph, so I just put it down low and labeled it as 0, -12, which is fine. And then I crossed through 1 and 3.